quick talk through the section 4.1 of basic concepts of probability in Triola. So let's look at these vocabulary words. An event, collection or of results or outcomes of a procedure. So just the collection of the results. The simple event is an outcome or an event that cannot be further broken down into simpler components. The sample space is for a procedure consists of all the possible simple events. That is, the sample space consists of all the outcomes that cannot be broken down any further. For example, we have a single birth as a procedure. The event would be that a girl is born. The sample space would be all the possibilities. So either a boy was born or a girl was born. In this case, it was just a single birth. But let's say you had 3 births. Now there's a lot of other possibilities if you went 3 in a row, right? One possibility is there's 2 boys and 1 girl. We would represent that as BBG or BGB or GBB. Those are all 3 different events that have the same outcome. So all simple events resulting in 2 boys and 1 girl. But the sample space is much bigger, right? 3 boys, first boy, second boy, third boy. Or how about 2 boys and a girl? There's the 2 boys and a girl, but a girl is born second. Eventually you get 2 girls, right, on the next 3, and then all 3 girls. So in order to find probability of something happening, it's what it was the event over the sample space. So what was the simple event over the entire space. So P of A, that's how we say it. P, the probability of A, denotes the probability of the event A occurring. And probabilities are between 0 and 1. So the probability of a girl happening, right? Of having a girl. We likely say they're 50-50, so it would be 50%. In this one, we have what we call a classical approach of finding a probability because they all have the same chance of happening. A boy is 50%, a girl is 50%. So we write how many times the event occurred over the total numbers that could happen. So if we did just the single birth, 1 girl over the 2 possibilities, 1/2, 50%. So there are 1/2 or 0.50. They're expressed as a fraction or a decimal and not percentages for probabilities. The law of large numbers just says that as a procedure is repeated again and again, the relative frequency probability of an event tends towards the actual probability. So what that means is, if you just flip a coin a few times, like 10 times, you expect, because they both have the same chance of coming up, 1/2 and 1/2, you accept 5 heads and 5 tails. But if you were to pull it out and do it right now, you might get 7 heads, right? You might get 3 tails. But if you continue the process of flipping the coin like 1,000,000 times, you'll get closer to that 50-50 split. So they said that 1/2 is considered the theoretical probability versus the actual probability that you're getting in your test. Example 3, it says, find the probability of dying when making a skydiving jump. So in a recent year, there were 3 million skydiving jumps and 21 of them resulted in deaths. We use the relative frequency approach here because we have however many deaths occurred versus how many jumps occurred. We can't use the classical because it's not the same probability of living and dying, right? So number of skydiving deaths that occurred over the total number of jumps. It's the total sample space. We're jumping out of the airplane. 21 divided by 3 million, you get 0.000007. So that would be the chance of dying going skydiving. Alright, let's go here next. I put this one in here. This is in the book. It's actually been updated. I'm pretty proud of the publishers here. They updated it due to my response, but it should say sex here. So they've been using the word gender incorrectly. It says you're born with a sex, and gender is something that's later defined. So it's something that's a little bit more broad. It's not black and white. Okay, then in this example we have the same kind of word being used, but we'll just change it to sex. So if 3 children are born, the sample space of sex is shown in this example. We have boy, 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 girl, etc. If boys and girls are equally likely, then those simple events are equally likely. So assuming the boys and girls are equally likely, meaning half, so 1/2 or 0.50, find the probability of getting 3 children of all the same sex when 3 children are born. So we can see right up here automatically how many the whole sample space is. 1, 2, 3, 4, 5, 6, 7, 8. And then there are 2 of either all boys or all girls, right? So you take the things you're looking for, the 2, since they're the same, equally likely, the two where they're all boys and all girls over the total number of possibilities. So the probability is 1/4 or 0.25. Another example would be this one here with texting and driving. It says it was found that 3,785 texted while driving during the previous 30 days, and 4,720 did not text while driving. Now what it says is, based on these results, if a high school driver is randomly selected, find the probability that he or she has texted while driving last 30 days. So you're not taking these two numbers and dividing them, because you got to find the total number of people. You want all of the sample, space. So these are the ones that texted. These are the ones that did not text. So you need to find the total number of people that you're sampling. So it'd be the addition of these, and then you would find the the probability, which would be 3,785 over the total, or if you want the other one, it's 4,720 over the total. So that's what we're doing here. We look at how many people total were sampled, and it would be 8,505. Now the question was the probability texting while driving. So how many people drove? 3,000, or texted while driving, 3,785 over that total. So 0.445 would be the probability that a high school driver is randomly selected that they text while driving the past 30 days. So be careful of what they're giving you in this information. You want to make sure you find a total of everybody so that you can have that base number. So you see the kind of things about the cautions and stuff. So complement. So they have this A with a bar over denotes the complement of A. So here would be the probability of A and then the complement. So the probability of A complement. Or you also say not A. They kind of be like it's not A, this is A, and this is not A. So it's the probability of that A not occurring. So for example, with the skydiving event in that problem we did, example 3, the probability of dying was this. The complement of that is not dying, so it'd be 1 minus that. So 0.9999993, right? So 1 minus that. So basically you're just subtracting the amount from 1. Why are you subtracting from 1? Because 1 is the 100%, or the whole, right? The 1 is the full probability of something happening. It happens all the time if it's probability of 1. X successes among N trials, significantly high number of successes if the probability of X or more successes is unlikely with a probability of 0.05 or less. So we're looking at 5% chance or less of something happen, and that would be significantly high number of successes. A significantly low number of successes is significantly low when the successes is the probability of X or fewer successes is unlikely to occur, unlikely with a probability of 0.05 or less. So again, 5, it's like, if you're looking at percentages, it's like 5%. We're looking at probability, so they just talk about the decimal form. But you're looking at 0.05. If it's less than 0.05, is something occurring is 0.05 or less, that is a significantly high or significantly low. So you just see how it's worded. X or more, or X or fewer. If it's, you're having this big of a thing is happening, and it's a lot of them, but it's a very small chance of that happening, and then that's significantly a high. If it's low going lower, fewer than this number, then it's called significantly low. So you're just basically looking at the 0.05 rule again here. So here's the review. Probability is an event between 0 and 1. Probability of an impossible event is 0. Probability of an event that is always certain to happen is 1. This is notation for the probability of A, and the notation for the probability of not A, or that it does not occur. All right, last part is about odds. This is a little challenging, but we just follow exactly what the definition says, and it's not so bad. So expressions of likelihood are often given as odds, such as 50 to 1, or like it says, 50 to 1. Here are the advantages and probabilities of odds. Odds make it easier to deal with money transfers associated with gambling. So that's where you're going to see it a lot, like casinos and lotteries, etc. Probabilities make it easier, calculations easier, so they tend to be used by statisticians, mathematicians, scientists, and researchers in all fields. So that's why we're dealing with more probability stuff than we do dealing with odds stuff. But let's look. The actual odds against, so the odds against something happening, the odds against the event A occurring are the ratio, the probability of not A happening. So against is the probability that you have something not happening over the probability that it does. It's usually expressed in the form of this A colon B, or A to B, where A and B are integers. And we reduce if we have like larger numbers. So 16 and 4, if we said the odds is 4 to 1 instead of 16 to 4 because you reduce them. The actual odds in favor of an event happening is the ratio probability of A divided by the probability not A, or the complement of A. So it's just basically the reciprocal of the odds against. But yeah, you have the 4 where you want it to happen, right? Payoff odds against event A occurring are the ratio of the net profit if you win to what the amount you bet. So payoff odds are the net profit to the amount you bet. All right, let's look at an example here. Actual payoff odds versus payoff odds. So if you bet $5 on the number 13 in roulette, now remember roulette's that one that goes around the circle and you throw a marble in and it lands on one of the numbers. Your probability of winning is 1 out of 38, and that's because your marble is going to land in one of the numbers out of the 38 spots. But the payoff odds are given by the casino as 35 to 1. So you have a 1 out of 38 chance of winning, but you're only going to be paid 35 to 1. $35 to every $1 if you win. So it says find the actual odds of the outcome of 13. So the ball wants to land on 13, or that's the number you choose. What's the actual odds? Well, the probability of 13 is just that one number over the 38 other numbers. And then the probability of not 13 is the other 37 numbers over the 38 numbers. So we're finding the odds now. So we have to find both of them. Probability of A happening, probability of not A. So the actual odds against are the probability of not A over the probability of A, and the actual odds in favor, probability A over probability of not A. And we're trying to find the actual odds against. So we're going to take the probability of not A, not 13, over the probability of 13. 37 over 38 divided by 138. If you do a little bit of reciprocal stuff, you flip this 138 over and you multiply it, or do this in a calculator, make a fraction, you're going to get 37 to 1, or 37 over 1, or 37 to 1. So that means 37 to 1 against you, right? These are the actual odds of the outcome of just hitting the number 13 on the roulette. 37 to 1, because there's obviously 37 other possibilities. B, how much net profit would you make if you win by betting $5 on 13? Okay. Well, because the casino pays off odds against 13 are 35 to 1, that's what was shown here. Even though the odds are 37 to 1, they pay you 35 to 1. We have a 30 net profit equals the amount bet, so you'd get $35 for every dollar you bet. If you're going to bet $5, you're going to get 5 times that, so $175. So you look at that kind of that payoff. The payoff is 35 to 1. So every dollar you get 35 bucks. So $5, 5 times 35. Last one, if the casino was not operating for profit or payoff odds were changed to match the actual odds against 13, how much would you win with the outcome? Well, the actual odds are 37 to 1. So if we bet $5 there, we take $5 times the 37 and have 185. So you'll notice that there's a $10 difference between the actual and what they do pay. So they actually still win when you win because they're not paying you the full amount, right? They collect the $10. They still collect money off of you playing, regardless if you win or lose. If you lose all of it. If you win, they still collect some of it. So that's why the casino is always winning. So this is a good example here for the homework problem that you have to do. So maybe keep this out and walk your way through it. Otherwise, hit show example in the homework, and it's a little confusing, but you'll be able to get through it. All right. Good luck. Put your questions in discussion.